Hey guys, this is your last video lesson here. We're talking about this one on number 4. This one's going to be a volume of a sphere inside your volume unit video lesson packet. So we're going to turn to the one that says for the volume of a sphere. You should also have your yellow sheet here. We're going to be looking at this equation right here about the volume of a sphere. And basically what it's saying is for the volume, or how much stuff a sphere, a 3D sphere can hold, we will do 4/3 times pi, which remember we will be using 3.14, the radius, which is the r, and we'll be taking that to the third power, or cubing it. So we're not going to square it this time, we're going to take it to the third power. So basically what we'll be having is we need to find this information, either the radius of what they give to us, or maybe the volume, and plug it into the right spots using this equation here, which you'll be able to use to solve the find for the volume of these things. So if we take this, our unit packet here, and we turn to the 4th page, which is right here on the back of the volume of a sphere, we are going to be able to use this to find out what's happening. So if we need to fill in, what we need to do is we want to fill in what the volume of the formula is. The volume of the formula is, once again, is 4/3 times pi, which we are going to use 3.14, and the radius to the third power, or cubed. And that is what we're going to be using to find for a sphere, a three-dimensional sphere, or how much stuff volume of how much stuff a sphere can hold, the capacity of what it has. Also, what they have here is a half a sphere. A half a sphere is called a hemisphere. We have a couple examples of a hemisphere. This one right here in number 3 is a hemisphere. Number 6 is a hemisphere. And in number 7 is a hemisphere. And a hemisphere is just half of a sphere. So when we get into these problems about finding the volume of that, we're going to treat it as a full sphere, find the volume as if this was a full sphere, and then divide it by 2, and it should be able to tell me my solutions. So let's jump right into what we have. And remember, if you need to, you have this little sheet here. You'll get this for the K-Prep test. You get to use this for this information. We're going to be using this formula down here at the bottom. 4/3 times the pi times the radius to the third power. So we want to get used to writing this stuff in and seeing what we have. So we're going to take the 4/3 times pi times the radius cubed. Now we look at what we have here. This is a sphere, and it tells us r is 3. That means that's the radius. So we don't have to do anything special about that. We want the radius. So we're just going to plug in the values. Our values here are 4/3. That always will be there. Pi, 3.14. And then my radius, which is 3 to the third power. And when I do that, I can put that all right here onto my handy dandy adding machine here. So I put it in here, 4/3 with parentheses times pi times my radius, which was 3 to the third power. So I hit caret right here above, underneath the clear, and 3. And when I get my answer, I get 103.04 is my volume. 113.04, and this would be units cubed. So that's how much stuff this sphere holds here. So if I do number 2 gives me an example. I just make sure I know which formula. I'm doing a sphere, so I need to write down my formula here. There it is, 4/3 times pi, right, times the radius cubed. I look what I have here. I know that I'm going to use the 4/3. It's always going to be used there. I know that the pi is 3.14. Now I need to know what my radius is. Well, this is the diameter. Diameter goes all the way across. I want a radius which goes halfway. So I need to take that 12 and divide it by 2 so I can get 6. I want halfway. And that's what that 6 is. So I'm going to use 6 to the third power. I'm not going to use 12. If I use 12, I have too big of units what I need. I'm not going to get the correct answer. So I just put those values back in my calculator. 4 divided by 3 with my parentheses times the pi times 6 caret to the third power, and voila, there it is. 904.32 is my units to the third power, or units cubed. For this one, I'll put u to the third power, cubic units in this case. Now it leads me to the ones for the hemisphere. And like I told you, we're going to treat it as if it is like a sphere, but then at the very end we have to divide it by 2 because we only have half of a sphere. So I'm going to use the same formula as say this was just a regular sphere. So what happens here, I put in what I know. I know I'm going to always use 4/3. I'm always going to use 3.14. I need to check to see if I have a radius or a diameter. Well, that's a radius because it tells me r. It's half of the diameter, so 5 to the third power. And so I'm going to put that into my calculator there. 4 divided by 3 times 3.14 times 5 to the third power, and it gives me 523.33. Now remember, that would be a full sphere. We want a half a sphere. So I need to take the very last part of that, is just take half of that. So I'm going to divide it by 2. And when I divide that by 2, I get my final solution to be 261.67 units to the third power, or cubic units in this case. So remember, a hemisphere is half a sphere. So what I did there was I just used the formula for a sphere as it was treated, found that to be 523.3. Then I took half of that by dividing it by 2. All right. So numbers 4 through 6 here are pretty much the same way, but what they want us to do here is they want to leave our solutions in terms of pi notation. So what we're going to do here is we are not going to multiply by pi. We're just going to leave it at pi. Like an answer, you may get 56 to the pi, 14.2 pi. We're not going to times 3.14. We're going to leave it as just with pi. So basically all we're going to be multiplying here is the 4/3 times the radius cubed. So I'll just do the same thing here. I'm going to do 4/3, write down my formula, radius cubed, put in what I know. Since we're not multiplying pi, I'm just going to leave it as pi there. And radius to the third power, well, this is a diameter. I need to know what half of that is because I want half to get my radius. So half of 13 is 6.5 to the third power. So what I'm going to do here, remember I want to leave it in terms of pi. So I'm just going to do 4/3 times 6.5 to the third power. And I get 366.16. And I got to put the little pi symbol right there, and that's units cubed. So the only difference there, that is the most exact answer, because remember, pi is a irrational number. It goes on and on and on and on forever. As these were just approximations, because we were just using 3.14 to approximate. This is the exact answer because we're leaving it saying, hey, this number, 366.16 times pi, is the actual volume. Because remember, we can only approximate what pi is because it goes on and on forever. So we just leave it as it is. So that's what pi notation is there that you see. So if I do the second one here, in this group of problems, I do the same thing here. I get 4/3 times pi times the radius cubed. Remember, I want it in pi notation for this. So I know I'm going to use the 4/3. I'm going to use the pi, but I'm just going to leave it in pi. I'm not going to do the 3.14. And my radius, this is a radius because it's halfway. I'm going to take it 12 to the third power. Put it straight into my calculator again. 4 divided by 3 times 12 to the third power. I left out pi because remember I'm leaving it just in pi notation. I get 2304. That right there is not my solution. And remember, I got to put the pi with it because I didn't multiply pi. So this is my pi notation. That right there is my units cubed, cubic units in this case. So basically this is saying 2,304 times pi. And that is the exact answer there for that volume of that sphere that we have. Same thing here that I can do for this one. The formula here, this is a hemisphere, so remember I'm going to treat it as like a sphere. So I do 4/3 times pi times the radius cubed. I'm going to leave it in pi notation, so I'm going to leave the pi by itself. So I'm just going to use 4/3 times pi, 9.3 to the third power. And so what I have here, I'm going to do this is a little 4.3, 4 divided by 3 times 9.3 to the third power. That gives me 1072.47. So that's the volume of the sphere. So then remember, I got to divide that by 2 to get the hemisphere. So when I divide that by 2 to get the hemisphere volume, I get 536.24. But remember, I want it in pi terms because I haven't multiplied it by pi yet. This would have had pi there too, by the way, I should say. And so there would be my solution there. So basically what I did there was just treated it as if it was a full sphere, found it in pi terms, divided just this number right here by half, and that's how I got to 536.24, and then I just left it as pi. I'm not dividing the pi by half because then that makes me have to put the pi back in later on or divide by 3.14 again, and I don't want to do that. I just dividing what I have by half. Okay? The last one here is just a word problem. There's not a picture if you would like to draw a picture, but we can remember to see what we have. So there's the formula again. I'm finding a sphere. Actually, I'm doing a hemisphere here. I'm going to treat it as a sphere. It says my radius here is 7, and I want to know the volume of the hemisphere. It doesn't say if it wants it in pi term or not, so I'm going to put it in both forms. So I'm going to treat it as it is right now. So I got 4/3 times pi. The radius is 7 to the third power. So I'm going to put it in pi terms the first time in pi notation. So I'm not going to multiply it by 3.14. So I get 457.33 to the times pi, and this would be cubic inches. That's what it would be in pi notation. If I wanted in, so this is pi notation. If I wanted in standard notation, remember I would take this and I would use 3.14. So I could take the 457.3 times 3.14, and I get 1,435.92. So basically, this would just be taking that number times 3.14 and getting my solution of 1435.92 inches cubic inches. This would be the approximation. This is the exact volume. They're both the same. They're both equivalent. They're both the same answer. So if one person gives you in standard form, the other person gives you in pi notation, they're both the same answer. They're both the same solution in this case. Now remember, I needed to do one last thing here because that's just the volume of a sphere. What's the thing that I got to do last? Well, I got to take both of these and divide it by 2. So if I take my solutions there and divide that by 2, find the hemisphere, I get 717.961 inches cubed. That's the hemisphere. So there's my solution there as a hemisphere. If I remember at the very end, I got to divide that by 2. If I divide this one by 2 again, I take the 457.3, divide it by 2. I get 228.65 pi, and that is there it is for the hemisphere, and that's what I wanted in this one. So this was the hemisphere as well. So just to kind of recap what I did there, I treated it as if it was a sphere, and then at the very end I had to take half of it because we wanted a hemisphere. So these were your notes for how to find the volume of a sphere. Use these to help you work on the other stuff, the IXLs and all that as you go. Remember to use your yellow sheet to help you, and you should do an okay job. Thank you very much.